Today we're going to do an Algebra 1 class on solving quadratic equations by using the quadratic formula. Up until now, we have used three different methods for solving quadratic equations. The first method that we used was factoring. The second method that we used was looking at a graph, so by graphing and finding the x-intercepts, or the zeros of the function. And the third method that we used was undoing a square. In the quadratic formula, the equation that we're going to solve is always going to be written in standard form. It's going to be written in the form ax squared plus bx plus c is equal to 0. When we have it in standard form, we have a formula or a rule involving our coefficients a, b, and c for solving for x. Our rule to find our values for x is going to be x equals the opposite of b plus or minus the square root of b squared minus 4ac, and that entire expression divided by 2 times a. So in order to solve a quadratic equation using the quadratic formula, the first step we need to do is to look or to make sure that the equation is in standard form, which is one side going to be equal to 0. So in question number 1, we want to solve the equation using the quadratic formula, and if necessary, we're going to take and round our answers to the nearest hundredth. So in question number 1, we don't have our equation in standard form. It's not equal to 0, so we need to make it equal to 0. So we're going to do that by subtracting 16 from both sides of the equation. We have 3x squared minus x minus 16 equals 0. And now we need to identify the a, the b, and the c in our standard equation so that we can use it in our formula. So our a, the coefficient of x squared, is 3. Our b, coefficient of x, is -1. And c is our constant term, -16. So now we're going to use it in our rule. And I'm going to go ahead and write that rule down right here so we can see as we substitute our values. So x equals the opposite of b plus or minus b squared minus 4 times a times c, and the whole expression divided by 2a. So I'm going to rewrite this now using my value for b. Well, the opposite of b, since b is -1, the opposite of that is +1, plus or minus b squared. So we're going to take -1 squared. When squaring a negative, make sure that you use parentheses or just recognize that that's the same as 1 squared. Minus 4 times our value for a, which is 3, multiplied by c, which is -16. And this whole expression is divided by 2 times a, or 2 times 3. Now let's use our calculator to help us a little bit. We're going to evaluate the part that is under the square root. So if we're going to do this, it's under the square root. We want to put parentheses around the -1 to square it, but hopefully you all recognize that that's just +1. And then we're going to subtract 4 multiplied by 3 multiplied by -16. This is our value that will be under the square root. So this value is going to be 193. So we have 193 all divided by 2 times 3, or 6. Well, 193 is not a perfect square, so we're going to use our calculator to approximate that value. So we're going to get the square root of 193. And I'm going to carry this out to the thousandths place so that I can actually round it after my next step. So 13.892 divided by 6. There's two values that we have here. Let's move this up and we can see this a little better. We have 1 plus 13.892 divided by 6. That gives us 14.892 divided by 6. And we're going to divide that and round to the hundredths place. So 14.892 divided by 6. That gives us 2.48. My other solution, using the subtraction, x equals 1 minus 13.892 divided by 6. That's going to be negative 12.892 over 6. And again, using that with our calculator, negative 12.892 divided by 6 to the nearest hundredth gives us negative 2.15. And those are our two solutions for this quadratic equation. Let's do another one. Again, it's not in standard form, so we need to get it in standard form. This time we're going to add x to both sides of the equation. And then in standard form, starting with the highest power of x, we have negative 5x squared plus x plus our constant 13 equals 0. We need to identify a, b, and c. In this case, a is negative 5, b is 1, and c is 13. So let's use those values in our quadratic formula. So starting with x equals, we want the opposite of b, so this is going to be negative 1 plus or minus the square root of b squared, 1 squared, minus 4 times a, which is negative 5, times c, which is 13. And this whole thing is divided by 2 times a, or 2 times negative 5. So to evaluate that, I need to multiply and add out the part that is underneath the square root there. So let's see what we get. Under our square root, we have 1 squared, or 1, minus 4, multiplied by negative 5, and then times 13. And we get 261. So we have the square root of 261, and that's divided by, the whole expression is divided by negative 10. Okay, again, we want to round to the nearest hundredth, so we need to know what the square root of 261 is. So the square root of 261, taking it out to the thousandths place, we have negative 1 plus or minus 16.155, all divided by negative 10. These are our values for x. Now we're going to split it into the two values. The first thing I'm going to do is negative 1 plus 16.155, which is negative 15.155, divided by negative 10. And we divide that, we get 1.52. Let me show you on the calculator for those of you who like to see that. Negative 15.155 divided by negative 10. Whoops, I did times. Let's hit that again. Divided by negative 10. 1.52. Okay, now we have our other side that we need to do with the subtraction. So when we do negative 1 minus 16.155, we get negative 17.155 divided by negative 10, and that's going to give us positive 1.72. And those are our two values, our two solutions for x for that quadratic equation. Let's take a look at a couple more. These are a little bit unusual because we don't have all three terms in our standard form, but we can still use our quadratic formula. Remember, our standard form is ax squared plus bx plus c equals 0. In this equation, notice I have an x squared term and I have a constant term, but I'm missing a b times x term, the linear term. So in this case, our b value is missing. It's 0, a is 5, and c is negative 20. And we're going to plug that into our quadratic formula again. Remember, our quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So let's put those numbers into our equation. The opposite of 0 is still 0. So we have 0 plus or minus, under our square root, b squared, that's 0 squared, which is 0, minus 4 times our value for a, which is 5, multiplied by c, which is negative 20. All divided by 2 times a, or 2 times 5. So now that 0 is just 0, so we end up with plus or minus. And when we multiply what's inside our quadratic, underside our root, we have negative 4 times 5 is negative 20 times 20. That's 400 over 10. The square root of 400 is 20, so we have plus or minus 20 divided by 10. We can actually do this. 20 divided by 10 is 2, so x is plus or minus 2. Again, we have two solutions. We can say x equals 2 or x equals negative 2. Okay, number 4, we're also missing one of the terms in our standard equation. Again, if I think of it as ax squared plus bx plus c equal to 0, our a is 2, our b is 10, and our c is missing, so its value is 0. So if we solve that using the quadratic formula, plugging our numbers a, b, and c into our equation, we have x equals negative 10 plus or minus the square root of 10 squared. And watch what happens here. We have minus 4 times your a, which is 2, times c, which is 0, all divided by 2 times a, or 2 times 2. Well, as I look at what's under the root here, this term, 4 times 2 times 0, is just 0. So I just have 10 squared here. So negative 10 plus or minus the square root of 100 over 4. And of course, the square root of 100 is 10. So we have negative 10 plus or minus 10 divided by 4. Let's look at the two choices there. X equals negative 10 plus 10 divided by 4. Well, negative 10 plus 10 is 0, and 0 divided by 4 is 0. Our other possibility is x equals negative 10 minus 10, all divided by 4. So we have negative 20 divided by 4, which is negative 5. And those are our two solutions using the quadratic formula. Just as a comment here, another method might have been easier to solve this quadratic equation. We could have very easily factored out a common factor of 2x and used factoring to solve this particular equation. Okay, an application. We've looked at applications of this type before. It says a ball is thrown into the air with an initial velocity of 5 feet per second from a height of 6 feet. So we have learned that our model for this equation is that the height above the ground at some time t is equal to negative 16t squared plus the initial velocity times time plus our starting height h0. So we have our initial velocity, our v0 is 5, and our starting height is 6. So our equation is going to be h of t equals negative 16t squared plus 5t plus 6. Now our second question asked, at what time will the ball hit the ground? Well, the height at the ground is 0, so we're going to find the 0 of this function. We're going to plug 0 in for h of t. So we have 0 equals negative 16t squared plus 5t plus 6. We want to solve this equation so we can use our quadratic formula. Our A is negative 16, our B is 5, and our C is 6. So let's put those numbers into our quadratic equation. We have x equals the opposite of b, so negative 5, plus or minus the square root of 5 squared minus 4 times our value for a of negative 16 times c, which is 6. And that whole thing is divided by 2 times a, 2 times negative 16. So let's use our calculator for that. And we're going to do 5 squared minus 4 times negative 16 times 6. And that gives us 409. So x equals negative 5 plus or minus the square root of 409, all divided by negative 32. Let's calculate our square root of 409. Take it out to the thousandths place. So we would have negative 5 plus or minus 20.224, all divided by negative 32. Okay, so let's do those two values. Our first one is negative 5 plus 20.224 divided by negative 32. So let's do that on our calculator. If we use parentheses, we can do negative 5 plus 20.224, close the parentheses, and divide by negative 32. And we get negative 0.48. For our second value, we want to do negative 5 minus 20.224, divide by negative 32. Again, we're going to use parentheses for our numerator. Negative 5 minus 20.224, close the parentheses, divided by negative 32. And I get positive 0.79 seconds, raised to rounded to the hundredths place. Okay, so as I look at these two solutions, this one says it hits the ground at negative 0.48 seconds. That's before we threw the ball. So this answer doesn't make sense in our solution, in our context of our problem, and our only answer is 0.79 seconds. Let's do one more part of this. This time I don't want to know what time the ball hits the ground. I want to know what time it's going to be 10 feet above the ground. So that means our height that we're looking at some time t is 10. So we have the equation 10 equals negative 16t squared plus 5t plus 6. This one's not in standard form yet, and we need to get it in standard form. So we're going to subtract 10 to get one side equal to 0. Subtracting 10 gives us an equation of 0 equals negative 16t squared plus 5t minus 4. So our A this time is negative 16, our B is 5, and our C is negative 4. Let's see what happens with this one. So we have time equals the opposite of B, negative 15, plus or minus our square root of 5 squared minus 4 times negative 16 times negative 4, all divided by 2 times negative 16. Let's see what we get this time. When I do the 5 squared minus 4 times negative 16 multiplied by negative 4, I get a negative 213 under our square root. So let's think about this for a minute. If I have a negative under a square root, I want to find some number multiplied by itself which is equal to a negative. But I know that any squared number has to be positive. So since we have the negative under the square root, there's no solution for this. There's no time at which this ball was 10 feet up at the ground, above the ground. So this has no solution. The ball never reached 10 feet above the ground. Okay, and that's our lesson for quadratic formulas, using the quadratic formula to solve quadratic equations.